Hey everyone, Mr. Kaczynski here, working through section CC of IXL's Algebra 1 skills. In my last video, we identified linear and exponential functions from tables. This time we're adding quadratic into it. I've got a couple examples of each, and I think we're going to use like a process of elimination here. All right, so first of all, this increase over here in the x values is always by 1 here, and that really doesn't change through IXL. They could make it more difficult, but they didn't. All right, so what's right here, if we take 0 minus -1, that's the difference between successive y values, we get positive 1. And here, if we go 1 minus the previous y value, we get 1. And here, if we go 2 minus the previous y value, we get 1. That's an indication of a constant increase of 1 that's linear. So that constant difference indicates linear. All right, here again on the left, we've got this pattern where x is always increasing by 1. Let's see what's happening with y. If we take 36 minus 12, we get 24. If we take 108 minus 36, we don't get 24, do we? We get 72. All right, so that eliminates linear. Let's move on to maybe it's exponential. Maybe it's because 36 divided by 12 gives us 3, and 108 divided by 36 is also 3. That indicates exponential. Example 3, again, increases of 1 over here. Let's check differences here. So if we do 128 minus 162, we get negative 34, like a decrease of 34, lost value in the y of 34. And if we do 98 minus 128, we don't get negative 34. We only get negative 30. All right, so that rules out linear. Let's check exponential. Let's do 128 divided by 162. Punching that into my calculator, it's about, I'll do these squiggly equal signs, about 0.79. All right, I'm doubting we're going to get that same thing here when I do 98 divided by 128. That's about 0.77. Although they're close, they need to be exact to be exponential. So that rules out exponential because that's not a constant. So what does that leave us with? It must be quadratic. All right, let's not get into y right now. I think we can save that for later. And also we've done some activities in videos past where we've written quadratic equations. But for right now, we know it's not linear, it's not exponential. That leaves us with must be quadratic in this activity. All right, one more time through these. Increases of 1. To be linear, we have to see a constant difference in the y values. So that's a difference of negative 6. And when I do 8 minus 14, I also get a difference of negative 6. That is definitely linear. All right, increases of 1 here. When I look for constant differences, I'm not going to see them. Okay, so that rules out linear. You can probably see this is exponential because 6 divided by 3 is 2, just like 12 divided by 6 is 2. So that's exponential. All right, and I see increases of 1. What happens when I do 225 minus 144? that gives me 81. And when I do 324 minus 225, that gives me 99. So that rules out linear. You can probably see that, especially if you look at the lower values. What if I do 225 divided by 144? What do I get there? It's about 1.56. Let's call it about 1.56. And when I do 324 divided by 225, I need to get that same value. And I don't. I get 1.44. Actually, it's exactly 1.44. So that leaves out exponential and leaves us with quadratic. All right, so that's identifying linear, quadratic, and exponential functions from tables. Good luck on that, and let me know how it goes in the comments.